All right, so class 6. So now you've used the human IK, you've auto-rigged something, and you've done some animation. First, obviously, you did the motion graphics, so you did a basic kind of simple rig, mostly using nonlinear deformers and various other ones. And then we did the human IK, and you did a little bit of animation there. So now what you're going to do is you're going to take your model, and you're going to rig it. But this time we're going to rig it by hand. You're going to place in joints, and then you're going to put all of the solvers, IK, FK, spline IK, blend shapes, all sorts of different things. All of the different nodes that you need in order to create a fully functional rig, and you're going to do it manually, okay? So that's it. So we're going to be doing that basically till the end, and then you'll do a final animation using this model, okay? So again, it can be whatever model you want. I really don't care. I would suggest doing something that you created yourself. A cartoony character, a realistic character, really doesn't make a difference. What I would say is it needs to be a bipedal character, okay? So meaning it's got to be on 2 legs. So even if you do an animal, it's got to be like anthropomorphic. It can't be just a straight up like 4-legged animal. That's a different kind of rig altogether. Okay, so that being said, the very first thing you need to do whenever you receive a model, or if you're working on your own, is you need to basically fix the model. Find if there's any weird errors, just clean it up in general, okay? So generally speaking, what I'll do is I'll select the model in object mode, and then I will press Mesh Cleanup. So you just go underneath make sure in the modeling menu set, go Mesh Cleanup, and then basically it should look like this. And what this is going to do is it's going to look for erroneous things in your model, any errors that exist, and clean them up. Okay, it doesn't work 100%. It's not going to catch everything, and in some cases actually it makes it worse. But it's worth a shot. So try it, see if it looks okay. If you find that it's not working well, try instead of doing cleanup matching polygons, click on select matching polygons. What it'll do is it won't try to do the fixing. It'll just select the things that it thinks that are errors, and then you can inspect them yourself and see if they are actually errors or if there's something odd. Okay. Okay. Another thing to do is look at the model and look for unmerged vertices or inside faces. So what you can do is you select the model, and normally you look at a model in 1 mode, which is the normal flat shaded mode. But if you hit 3, it'll go into like subdivision mode, where it basically rounds out the model. If you push that, because sometimes it's hard to tell when it's in the normal mode, if you push that, it'll actually make it more obvious to find some errors. So if you look at here, I don't know if you could tell. Let me Control +++. You can see here. There's a vertice that's not attached, right? So you can, and you'll notice that the edge loops almost like point an arrow to it. You can see like it's almost like they're pointing to this thing, but it's easier to find when it's in 3 mode. So you look for anything that looks like a weird imperfection. Also, what often happens is that you'll get something that looks like this. It's not so obvious here. Basically, I don't know if you can see, there's a little line right here, okay? And what it is that if you were to look inside of it, there's actually a face that's inside of this model, okay? So it's not just one hollow sheet, it's actually like being separated by one face all the way through. This is really common. You'll see happen like in arms or legs or on fingers and things like that, where you have projectiles coming out. And all you got to do to fix this is just go in and delete the faces on the inside, and that will clean it up. Obviously, you just have to merge the vertices here. Besides that, what you would want to do is go to the UV editor, make sure all the UVs look fine. Review the topology just in general. You know, look around for anything that looks kind of odd. If there's a lot of poles, meaning, you know, it has more than 4 edges going into a single point. 5 are okay. You're going to have those, but you don't want to have 6 or above. N-gons, faces with more than 5 sides. Obviously, you're familiar with that. Make sure all the edge loops look nice, that they go all the way around, that they terminate. They don't just randomly stop in the middle of a form. Generally the grid flow, so on and so forth. Okay, so the first thing you're going to do basically is put the skeleton in. Okay, so the skeleton is more or less the the base to which everything is built on. Okay, now we're gonna bind our model to the skeleton, but that's not even necessarily. You don't have to do that. In our case, that's the easiest way to do it, and it's the cleanest way to do it. And if you're gonna put something into a game, it's the best way to do it. But it is possible to actually bind a model to other objects or whatever. Even when you do that, though, you still usually use the skeleton tool inside of Maya. The reason being is that it has some other attributes to it that just make it more well suited to basically determining how the body is going to bend. But anyway, just as the skeleton is like that basic underlying structure for the human body, so it is also in 3D. Okay, so you have these joints. The joints are actually the little circles here. This is a bone, and then there's the next joint. The bone doesn't matter at all. That's just a visual signifier, and for that matter, even the joint kind of doesn't. It's just a visual representation. You can actually change how these look. There's like an option in preferences and stuff. The main thing is that these are just the areas of articulation. Okay. You are going to have to, after you lay out your joints and you place them, and we've already kind of done this a little bit when we did the human IK. You're going to want to change the local rotation axis. Okay. So just as you know, I'm going to turn on Maya, and then I'll pause this for a second while it turns on. All right. So just to kind of give you an example, when you have an object, let's say let's just take a cube here. All right. I have this cube here. You'll notice that, when you rotate this, you can see that it has a local axis, right? It's not the same, like if I don't have it in here anymore, let me display, heads up display view axis. I thought I did that, hang on a second. Heads up display, view cube. That's not a view cube, but okay. But that's a view axis. I don't know why that didn't show up before. So anyway, if you look, you can see world is up and Z is whatever you can see down here. But you see, obviously, this has its own. It doesn't have to be what the world is, right? And so just like that, and if this was longer, you can see it runs across it follows the direction of the object itself, okay? And basically, that's what you want to do with your joints. You want them to follow this, that they follow the flow of your object, okay? Generally speaking, this is what the rule is, okay? X always points down the joint chain, okay? So X is always coming down. And that's basically what we call our rolling axis, okay? Now, what we need to do is after you draw a joint chain, sometimes it won't quite look the way that you want. Like this one is actually problematic. You'll notice that the Z points down here. I guess the Y is always pointing to the right, which is fine. But you want it to be kind of consistent. Sometimes when you draw joints, they won't actually be consistent. So let me turn this back on, and I will draw some joints so you can kind of see what I'm talking about. So let's go. Okay. Like that. Boom. And actually, this probably won't even be terrible because of whatever, but let's just do this. Okay. Now, if you look, notice how the Z is pointing this way, Z is pointing this way, Z is pointing this way, this way, this way, that way, and then it flips. Now it's going this way, and now it's going to the right side. So it doesn't, it's somewhat inconsistent. The X is good, it's always going down, and the Y is always pointing up, which is fine, but the Z is not always pointing in the right direction. So sometimes when you draw the joint chains, they don't always go the direction you want, so you actually have to fix them at times, okay? In order to make sure that they rotate the way you want. The reason why, watch this video, you'll see, but basically what ends up happening is that you'll get what's called Gimbal Lock, and it's when two axes end up being in the same, Control Z, Q, okay, cool. When you have two axes, more or less, line on top of each other. Just because we've been working in this rotation mode, either object or world. So you'll notice when I rotate in world, no matter what, it always keeps the world. When I do object, I'm just in the tool settings here, it rotates with the object. But that one's also not real. If you go to gimbal, that's the actual rotation. Okay, and basically what it is that the computer will calculate one axis, then the next, and then the next. Okay, so it'll read one, then done, then done. And you can actually, if you go to the attribute editor of any object, and you go to not the shape node, but the transform node, you'll see that it has rotation order. So see this says X, Y, Z. That means it's going to read Z, then Y, then X. It goes backwards. It doesn't make any sense. Which means if I rotate Z, you'll see it rotates all three axes. Okay, it's almost like it's parented to them, right? So it's almost like all three of them parented to Z. So let's say I rotate this. Then if you see if I rotate Y, it's going to rotate X, but it does not rotate Z. Okay, because X happens after it, but Z's already happened. Okay, and then you'll see if I rotate X, it doesn't affect any of them because it's the last one to get calculated. So what ends up happening though is this. Z you can see is fine. I get all, no matter how I rotate this, I still have all my axes in the directions that I want. But if I take my Y and I rotate it, because that one happens, only moves one but not the other, I can get what's called Gimbal Lock. And basically what ends up happening is that if I rotate it this way, I no longer have an axis. You can see I can't grab anything for it to rotate in the other direction. Okay? So, to make a short story probably longer than it needs to be, what you need to do is you want to make it so that X always runs down. That's always your roll axis. That's fine. But you want to make it so that Z is the primary axis. So that however your joint's being moved, Z is the most likely one that you're going to bend it in. So for instance here, like the knee, right, only bends in the one direction. So I'm going to make sure that Z goes this way because that's the most common direction for it to go. So that it'll flex, and that way all the other axes are available. I wouldn't want to make Y there because as soon as I would bend it on Y, then the Z and the X would overlap with each other, and I'd be all like immediately in Gimbal Lock. So I try to make it so that the axis I'm most likely to use, the main axis, I want to make sure is Z. Okay, and we'll do it down here. So here's more of that stuff, just kind of talking about the same thing. You can read through it. It'll probably be beneficial. When you do place joints, you want to make sure, again, like we talked about before, you have to take a couple of different things into account. One is going to be anatomy. So think about where the joints actually would exist anatomically. Then think about the geometrically, topology-wise. So you're going to want to put the joints in the center of mass, generally, in the center of the volume. And you're also going to put it in the center of edge loops. So if I have 5 edge loops in here, I want to put it on this center one. Okay. Your next assignment, basically, what I want you to do is just prep your model and place your skeleton inside of it. Okay. So that's going to involve, you can watch these tutorials and that should guide you through most of it. And that's basically it. All right. So good luck.